Welcome to Coach Eichner's Math. Today we'll be talking about indirect measurements. So, the important part here is we've been talking similar triangles, and similar triangles can be used in indirect measurements. So looking at example number 1, find the value of x. So we're missing this piece right here. The first thing is I've got to look at it and go, do I have similar triangles? Well, we know we have one angle and they share a second angle. So by angle-angle similarity, I know that I have similar triangles. So because they're similar, sides are proportional. So 10 over 22 would be proportional with 5 over x. Go ahead and cross multiply, say 10x, 10 times x, equals 5 times 22, which is 110. Divide both sides by 10. We're going to find that x equals 11. And by using our similar triangles, we're able to show or find missing values. Looking at example number 2. Find the value of x. So here, parallel lines, okay, tells us these are corresponding angles. Tells us these are corresponding angles. So again, by angle similarity, I can now tell that my sides are proportional. So I would say 8 over x equals 3 over 6. Notice the way I'm doing this, 8 and 3 were on my small triangle, 8 and 3 were on top. X and 6 were on my large triangle, x and 6 are on the bottom. So when I cross multiply, 8 times 6 is 48, which equals 3 times x, which is 3x. Divide both sides by 3 to figure out what x is. X would equal 16. Looking at an example number 3. This time, instead of just giving you a bunch of triangles, they actually put it into perspective for you. Eventually, you'll be making your own pictures based off of words. So looking at my small triangle, again, we know that they share an angle, we know that they share an angle, we know that they share an angle. They don't share an angle. But we can tell that these are both perpendicular to the ground, which is how we talk about our 90 degrees. So that's where our angle-angle similarity comes from. Okay? So our sides are still proportional. So I'm going to say 24 over 21 equals 56 over x. So this time I did it a little differently. I said 24 and 21. My small triangle are together. 56 and x are my big triangle. They're together. Now, 24 is on the bottom and 56 is on the bottom. They're both on the top of my triangle, or on top of my ratio. 21 is my rise, x is my rise, and they're both on the bottom. So 24 times x equals 21 times 56. So go ahead and multiply that together, and you find that 21 times 56 is 1176. Divide it by 24. X equals 49. So now to take those pictures and put them to practice, they're going to give us words, and it is our job to create our own pictures. So look at example number 4. When Stephanie stands 2 feet from a lamppost, so I need a lamppost, putting off light, and Stephanie stands 2 feet away, so there's 2 feet, and here's Stephanie. Her shadow is 3 feet long. So her shadow is 3 feet long. If Stephanie is 5 foot tall, how tall is the lamppost? So I didn't do a great job with my picture here. The lamppost would be just a little bit taller than Stephanie is. And the shadow would create a triangle where we're going to have 2 people standing straight up, which is my 90-degree angle, and my angle right here that we share. So I can say 3 over 5, because Stephanie's shadow is 3 feet and she's 5 foot tall. And we can say the bottom piece here is the 3 and the 2 put together. 5 over x, because x is how tall the lamppost really is. So multiply together. 25 equals 3x. Divide by 3 on both sides. X would equal 8 1/3 feet. So moving down to the next one. Each time Old Faithful in Yellowstone National Park erupts, rangers can estimate the height of the geyser by comparing it to the height of a tree. First, the rangers locate a tree with the same height. The shadow of the tree is 93 feet at the time that the shadow of a ranger, 6 foot tall, is 4 foot. Find the height of the tree to the nearest foot. So, this is all based off the fact that a sun is setting up in the air, and we've got a tree, and we know that the tree is X feet tall, and we know the shadow from the tree, okay, the shadow of the tree is 93 feet. So that sun casts the shadow, so I know that there's 93 feet on the bottom. I know that it's X. At the same time, with the sun, we've got a park ranger. You're going to know he's a park ranger because he's going to be wearing a big old bucket hat. And he's going to have a shadow as well. So at the time, this 6-foot ranger is going to have a shadow of 4 feet. And again, based on the sun and the angle that is coming down, we're creating triangles. So I would say 4 over 6 would be equal to the shadow of 93 over x, the actual height. So I'm going to multiply and say 93 times 6. So 93 times 6 would give me 558, which would equal 4x. Go ahead and divide both sides by 4. I would find that the height, or x, would be 139.5, which rounded to the nearest foot would be 140 foot tall. Okay. So looking down below, a mirror is placed on the ground 8 feet from Ricky and 19 feet from a flagpole. Ricky can see the top of the flagpole in the mirror. If Ricky is 6 foot tall, how tall is the flagpole? So this one's just a little bit different. We're going to draw Ricky standing over here. He's looking at a flagpole. He's looking at a mirror on the ground. And then the mirror is placed 8 feet from Ricky and 19 feet from a flagpole. Put some stripes on there. Okay. So, right now, knowing that Ricky is 6 foot tall, we want to know how tall is the flagpole, because his line of sight is looking at the top of the flagpole. So we're going to say 6 over 8 is equal to x over 19. Multiply it together. 19 times 6 is 114. 19 times 6 is 114, which is equal to 8 times x. Divide both sides by 8. We're going to say that x equals 14.25. So I can say here that the height of the flagpole is 14 1/4 foot high, or 14.25 feet high. Either way you want to say it is acceptable. This has been Coach Eichner's Math. I appreciate you watching. Hope you've enjoyed, and have a great rest of your day.